In this example of a system, we have our first equation as 3x plus 2y minus 4z is equal to negative 12. In our second equation, we have negative x plus 5y plus 2z equals 16. And our third equation in the system is negative 2x minus 4y minus z is equal to negative 1. In a system, our ultimate goal is to get a ordered pair, or triple in this case, of all the values of each variable. We have three variables, x, y, and z, and at the end, we want to get an ordered pair of all their values. To do so, we need to combine the different equations in the system. So first what we want to do is find two equations that we can combine together to create an equation with two variables. So I chose 1 and 2. 1 and 2, we can't just combine them because we have no variables to get rid of by just combining them, so we had to multiply. I multiplied the bottom equation by 2, and that way we'll end up with 4z right here, and then we can get rid of the z variable. So multiplying it, we move on to step 2, and we get the plus 4z, and we also have to multiply the rest of the equation, so we get negative 2x plus 10y plus 4z is equal to 32. So now that we have this, we can eliminate both z variable terms in each equation and then combine the rest of the equation to get an equation with only two variables. So we get x plus 12y equals 20, and I labeled this as equation 4. And now we just need to repeat the same process except for with changing out the second for the third, or doing the first and the third. It doesn't matter which equations you combine, but you can't do the same two again. So we want to do the same exact thing we just did, get rid of the z to get a new equation. So I combined 1 and 3, and I had to multiply at the bottom by negative 4 so I could get rid of our z. And a negative times a negative equals a positive because we want to make sure they're opposite signs, or else we can eliminate them. Multiplying the whole bottom equation by negative 4, I got 8x plus 16y plus 4z equals 4. So then we cross out negative 4z and plus 4z, eliminating both z variables, and adding / combining both equations together, we have our fifth equation, which is 11x plus 18y is equal to negative 8. Now that we have two equations with two variables, we can combine those to get a one variable equation using the same method. So if we pin those two together, we can multiply the top one we can multiply number 4 by negative 11, so we have negative 11x and 11x. Moving over to step 6, now that we have negative 11x and positive 11x, we can eliminate both of those, and adding or / combining the rest of the equations together, we have 114y is equal to 228. And now we just have to solve for y in this one step equation, so we just divide 228 by 114 and get y is equal to 2. Now that we have y is equal to 2, we can actually just plug in y back into either the fourth or the fifth equation to get x. So I plugged y back into our fourth equation. So now that we have y, we can times 18 by 2 to get 36, and then subtract 36 from negative 8, and then we get 11x is equal to negative 44, dividing negative 44 by 11, and we get x is equal to negative 4. To find our last variable value, which is z, we just need to plug in our new x and y variable values into one of the original equations. I chose 1 and inputted all of our known values, so 3 times negative 4, 2 times 2, and then we just have negative 4z and equals negative 12. So then multiplying out each of our inserted terms, we have negative 12 plus 4 minus 4z is equal to negative 12. Adding like variables, we have negative 8 on this side, so now we need to add negative 8 to this side to get rid of it, and add negative 8 to this side. So we'll end up with negative 4z is equal to 4. Dividing 4 by negative 4 will give us z is equal to negative 1. And like I said in the beginning, we need to combine all of our variable values in an ordered triple to get our final solution and answer, which is negative 4, 2, negative 1. And now we're done.